Welcome to my channel Glory with Mathematics. Please subscribe, like and share. Dear students, let us do the activity lines and angles. Objective: to study about lines and angles and their properties. Materials required: white chart paper, geometry box, color pen. Theory: straight line. A line is connected set of points that extends forever in both directions. That is, a straight line has no definite length. Here in the figure, PQ is a straight line. It can be extended in both the directions infinitely. Then line segment. A line segment is a part of line with two endpoints. A line segment has a definite length which can be measured. The line segment AB in the figure is the same thing as the line segment BA. So here in the figure, AB is a line segment. It has a fixed length and it has two endpoints. Then ray. A ray is also a part of the line having one fixed point and the other point does not have an end. So it means that a ray has one terminating end and the other end is extending infinitely. Then a point. A point is represented by a dot and is used to tell the exact location in space. It does not have any length, width or height. In other words, it has no size. So point is termed as a dimensionless entity. Then angles. The figure formed by two rays with the same initial point is called an angle. Here in the diagram, ABC is an angle. BA and BC are known as the arms and B is the vertex. The initial point B is known as the vertex. BA and BC are the arms or sides of the angles. Then acute angle. The angle whose measure is greater than 0 degree and less than 90 degree is known as acute angle. Here in the figure, angle ABC is an acute angle since 0 degree is less than angle ABC is less than 90 degree. Then right angle. An angle whose measure is 90 degree is called a right angle. Here in the figure, angle ABC is a right angle and here we can say BC is perpendicular to AB. Then obtuse angle. An angle whose measure is more than 90 degree but less than 180 degree is called an obtuse angle. Here in the figure, angle ABC is an obtuse angle since 90 degree is less than angle ABC is less than 180 degree. Then straight angle. An angle whose measure is 180 degree is called a straight angle. So here Angle ABC is a straight angle because its measure is 180 degree. A straight angle has two right angles. Then reflex angle. An angle whose measure is more than 180 degree but less than 360 degree is called a reflex angle. Here in the figure, angle ABC is a reflex angle because 180 degree is less than angle ABC is less than 360 degree. So example of reflex angle 220 degree, 270 degree, 200 degree like this. Then complete angle. An angle whose measure is 360 degree is called a complete angle. Then complementary angle. When the sum of the measures of two angles is 90 degree, then the angles are called complementary angles. Example, here 60 degree and 30 degree. 60 degree is the complementary angle of 30 degree and 30 degree is the complementary angle of 60 degree. Then supplementary angle. When the sum of the measures of two angles is 180 degree, then the angles are called supplementary angles. So here 60 degree and 120 degree. 60 degree is the supplementary angle of 120 degree and 120 degree is the supplementary angle of 60 degree. Then intersecting lines. When two lines have one common point, they are known as intersecting lines. And the common point is known as point of intersection. So here in the example, AB and CD are two intersecting lines in the figure and O is the point of intersection. Then transversal. A line intersects two or more lines at distinct points is called a transversal. For example, here P is the transversal. In the figure, you can see P is the transversal because it intersects the two lines L and M in two distinct points. Then angles made by a transversal. So here look at the figure. Line L and M are caught by transversal P. So 8 angles are formed. 1, 2, 3, 4, 5, 6, 7 and 8. So when a transversal cut or intersect two lines, then 8 angles are formed. So what are the angles formed by a transversal when it intersect two lines? So here 8 angles are formed. So here there is a table. So exterior angles are 1, 2, 7 and 8. Pair of corresponding angles are angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8. So there are 4 pairs of corresponding angles. Then pair of alternate interior angles. So these are angle 3 and angle 6, angle 4 and angle 5. So these are two pairs of alternate interior angles. So then pair of alternate exterior angles. So angle 1 and angle 8, angle 2 and angle 7. So there are two pairs of alternate exterior angles. Then pair of interior angles on the same side of the transversal. So angle 3 and angle 5, angle 4 and angle 6. So these are two pairs of interior angles on the same side of the transversal. Then parallel lines. So what do you mean by parallel lines? When two lines never intersect each other, or when the distance between the two lines, that means the perpendicular distance between two lines is always constant, then these two lines are known as parallel lines. Here in the figure, A, B, C, D are two parallel lines. That means they will never intersect each other, and the distance between these two lines at any point is constant. So here we can write AB parallel to CD by using symbols, or we can write AB is parallel to CD. So when a transversal intersects two parallel lines, eight angles form. So like we have discussed earlier, when a transversal intersects two lines, then eight angles are formed. So here also when a transversal intersects two parallel lines, eight angles are formed. So here in the figure, the angles are marked as angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7 and angle 8. So what are the properties when the transversal intersects two parallel lines? So following properties are satisfied by using these eight angles. First, when a transversal intersects two parallel lines, then each pair of corresponding angles are equal. So here in the figure, angle 1 is equal to angle 5, angle 2 is equal to angle 6, angle 3 is equal to angle 7 and angle 4 is equal to angle 8. Then second property, when a transversal intersects two parallel lines, then each pair of alternate angles are equal. So here in the figure, angle 1 is equal to angle 8, angle 2 is equal to angle 7, angle 3 is equal to angle 6 and angle 4 is equal to angle 5. Then third property, when a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal are supplementary. So here in the figure, angle 3 plus angle 5 is equal to 180 degree and angle 4 plus angle 6 is equal to 180 degree. And its converse also true. If a line or a transversal intersects two lines such that the each pair of corresponding angles are equal, then they are parallel. The lines are parallel. Second, if a transversal intersects two lines such that each pair of alternate angles are equal, then the two lines are parallel. Then next, if a transversal intersects two lines such that the interior angles on the same side of the transversal are supplementary, then the two lines are parallel. So pair of angles. So there are some relations between the angles. First, adjacent angles. So look at the figure. These are the examples of adjacent angles. When two angles have a common vertex and common arm, when the two angles have a common vertex and a common arm and their non-common arms are on different side of the common arm, then the two angles are known as adjacent angles. So in this given figure, angle AOC and angle COB are adjacent angles as they have common vertex O. and common arm OC. And non-common arms OA and OB are on different sides of the common ray OC. When two angles are adjacent, then their sum is always equal to the angle formed by the two non-common arms. That means angle AOB in this figure, angle AOB is equal to angle BOC plus angle AOC. So, but look at the figure, angle AOB and angle AOC are not adjacent angles because they have a common vertex O, but the arms, the non-common arms OC and OB lie on the same side of the common arm OA. Then linear pair of angles. If the non-common arms of two adjacent angles form a line, then these two angles are called linear pair of angles. Linear pair of angles, that means a pair of angles whose sum is 180 degree, but they are adjacent to each other. They are adjacent angles. So here in the figure, angle AOC and angle BOC form a linear pair of angles. Then vertically opposite angles. Two angles are called a pair of vertically angles if their arms form two pair of opposite rays. In other words, when two lines intersect each other at a point, then there are two pairs of vertically opposite angles. So here look at the figure. So here AB and CD are two lines which intersect each other at point O. So angle AOC and angle BOD are vertically opposite angles, and similarly angle AOD and angle BOC are vertically opposite angles. That means angle P vertically opposite to angle N and angle O vertically opposite to angle M. Thank you.